like to post a quick review of how to perform antibody identification based upon a positive 3-cell screen. I'm going to post these two cases, or this case, the 3-cell screen and the A cell, and the A panel to Moodle. Please print those two sheets off, the 3-cell screen and the A panel, and follow along with this video lecture. So we have a 3-cell screen here, and when we perform a 3-cell screen, we want to interpret it as either negative or positive. So step 1, interpret this panel. And you can look at our panel that we have 0 reactions in our immediate spin, 0 reaction in our 37 degree, but we get to cell number 2 at AHG and we have a positive result. So at this point, what we do with this 3-cell screen is call it positive. Remember, this is just a screen. The screen tells us that this patient has an unexpected antibody. So step number 2, identify antibody. So to perform an antibody identification, we need to perform an A panel. We have to make a little bit of adjustment so we can get this all on the same screen here. Okay, so I've gone ahead and I have performed all the work required of this A panel, of this 11-cell panel. And what we need to do first is highlight all of our negative reacting cell lines. Negative reacting cell line would be cell line number 1, cell line number 2 is positive, cell line number 3, negative, cell line number 4 is positive, cell line number 5 is negative. Next cell line is positive. Here we have a negative reacting cell line. Another negative reacting cell line. And the last 2 cell lines are also negative reacting. I'm going to back up just a moment. And do a quick review of heterozygous versus homozygous. Heterozygous. Let's use KEL for example. So if I have a panel that has big K and little k, a heterozygous combination would be a positive big K and a positive little k. A homozygous combination positive for big K, negative for little k. That is a homozygous big K combination. I can have this homozygous combo, negative for big K and positive for big K. So remember, when we are performing rule-outs, we are always looking for a homozygous combination. Positive for one, negative for the other. The only exception to that rule happens to be big K, is KEL. For KEL, we can use 3 heterozygous rule-outs. For all the other antibodies, we have to have a 2 combination homozygous to perform a rule-out. So the first reason we have highlighted all of our negative reacting cell lines is we want to find positive antigens in our negative reacting cell lines. If you remember, I said there's always two things we have to have in a test tube. We have to have something that we know and something that we don't know. In this panel, we know that cell line number 1 has the D antigen on it, and we are testing it against unknown plasma. So if I have a positive antigen in a negative reacting cell line, I know I can rule that combination out because that antigen there is not involved in this patient's antibody. So big D has no anti-theatical partner, so we need two D's to rule out. Looks like I can use cell line 1 and cell line number 3 and rule out big D. Now remember, when you're looking at these panels with the RH system, big C and little c are not together. So make sure that you compare them appropriately. So let's look at big C. We can compare big C to little c, and there is a homozygous combination. We can rule out big C there. We can't here because that's a heterozygous combination, big C positive, little c positive. It looks like our only other choice is the last cell line where it's positive for big C and negative for little c. So we have effectively ruled out C. Next is big E. And again, make sure that you compare big E against little e. Positive big E, negative little e is one combination. And it looks like that's the only one. So on the side of my paperwork, I'm going to write down one big E. I need two rule outs here, so I need to find one more big E. Little c. Looks like I have a positive little c and a negative big C, so there's one homozygous combination. This cell line is not going to work because it's positive for both. It looks like this cell is going to work for us, so I have ruled out little c. Let's look at little e. Cell line number 1 will work, as will cell line number 5, so we have ruled out little e. For now, please disregard F, CW, and V. Disregard KPA through JSB. So let's move on to Kel. This is kind of our rule breaker. Remember, we can have 3 heterozygous combinations to rule out big K. It looks like we have 1, 2, so we need one more big K to perform a rule out. Little k is going to be simple enough. Cell line number 1, cell line number 3. We have ruled out little k. Let's move on to Duffy A. There are no positive Duffy A antigens on negative reacting cell lines, so I can't do anything with Duffy A right now. Duffy B. Looks like I can use cell 1 and cell 3, and I've effectively ruled out Duffy B. JKA, I can use cell line number 1 and cell line number 3, are my homozygous rule outs. JKB, I can use cell line 5, just cell line number 5, so I need one JKB. The XG system is like the D system, it stands alone, so I just need 2 XG. There's one, and there's one, and I have ruled out XG. Next I have Lewis A. I can use cell line number 1 and cell line number 7 to rule out Lewis A. Lewis B, cell 5 and 8 will rule out Lewis B. Big S and little s are anti-theatical partners. And it looks like I only have one rule out on big S. So I need to find one S. Little s cell line number 3, and our last cell line. So I ruled out little s. Big M, antitheetical partner, is big N. It looks like I can use cell line number 3 and 5 to rule out M. N, I have 2 rule outs. We've gotten rid of big N. P is like X, G, and D. I can use the plus S or a plus to rule it out. I've gotten rid of P. Lutheran A is our low incidence antigen. You'll see that there are no positive Lutheran A cells in this 11-cell panel. So we're going to move on to Lutheran B, which is high incidence. Rule that out. Let me come back to my rules. Number 3, perform rule out. We just performed our rule outs. We ruled out a variety of antigens, narrowing down our field. Step number 4. Let's see if we can match a pattern. But I'm talking about a pattern of reactivity. Let's go back to our A panel. So of all of the antigens and antibody combinations we've ruled out, we're left with E, Kel, JKB, S, and Duffy A. So take a moment and just look at the pattern of reactivity of big E, Kel, JKB, S, and Duffy A. And what I mean by look at the pattern of reactivity, who's positive reacting in positive cell lines and who's negative in negative cell lines. And we'll cut to the chase. Let's look at Duffy A. It's negative reacting on a negative cell line, positive on a positive reacting cell, negative, positive, negative, positive, negative, negative, positive, negative, negative. So that really gives me a good gut indicator that Duffy A is most likely the antibody involved in this patient's positive antibody screen. We do have a few rule outs we have to take care of. We have an outstanding E, a Kel, a JKB, and an S. Well, we can go back to our 3-cell screen and see if we can utilize this at all. We've already put the work into it, so first thing we want to do is highlight our negative reacting cell lines, which is cell line number 1 and cell line number 3. So let's see if we can find a big E. Looks like we're not in luck, so we still need one big E. Let's look to our Kel. Well, we can use cell line number 1, and we have 3 heterozygous Kel combinations. So we have effectively ruled out Kel here. Let's move on to JKB. We can use cell line number 1 for JKB. So we have ruled out JKB. And we're looking for an S. Looks like we can use cell line number 3. And we've now ruled out big S, leaving with an outstanding big E, but narrowing down the field to Duffy A. I can go find one more cell line off of my B panel to rule out big E. So number 4 was match the pattern. Step number 5, rule of 3. we have to have 3 positive cell lines and 3 negative cell lines. And if we look at our A panel, I believe that we match that criteria. Here we have 1, 2, 3 negative reacting cell lines, and here we have 1, 2, 3 positive reacting cell lines. So after we find that big E on our B panel, we are at the 95% confidence interval that this patient has Duffy A antibody. Number 6, we now need to screen units, screen donor units for Duffy A. And then 7 would be perform a cross match with those units. I will post both the 3-cell and the A panel to Moodle for you to follow along with. As always, contact me with any questions.